This is Robin. So we will be doing the question number 15 from the GATE Physics 2023 exam. So as you can see, this question is about the hydrogen atom, right? So you can quickly look at this. So in order to start the question, we should first introduce what is happening. So there are so many operators given in the question. There is H Hamiltonian, there is L, which is orbital angular momentum, there is Lz, which is the Z component of it, and so in option you are asked if you have one state of the hydrogen atom, then it is eigenfunction of which all sets of operators. Okay, so now this is very tricky question. People in the very first case, they can make mistake. Most of the people will choose option A because every state of the hydrogen atom, if you represent by this, so I would motivate you how to be very correct, which is like this. Okay, so if you represent the state of the hydrogen atom in the spherical polar coordinates, it's like this. There is a radial part, there is a spherical part. Now in general, it is the eigenfunction of H, L square and Lz, right? In general. But this is a special case. They have specially said it's one state. Now you have to be very careful. Now this is something special about the 1s state, that it is spherically symmetric. Now what does that mean? The YLM is constant actually in this case, and you remember this one should you should remember this is a constant. Now normalized one is 1 by square root 4 pi. Okay, so fine, that's true. Now what the question is, uh, if that is the case, what about the L operator? Because that is the another option which you see where L is also, they are claiming the eigenstate of that. Is it possible? Let's do it. So it's very simple. You don't need to remember the things and all. You just say it is R cross P. Okay. So in spherical polar coordinates, this is like this. Okay, good. Now what is the del operator? It's very, this is the most simplest operator you can remember. It is this r hat plus theta 1 by r del theta plus phi 1 by r sine theta del phi. Now this and this cross product would be 0. Good, and r would cancel, so minus IH bar would be there outside, and you would say it would be this with theta and r theta. Okay, r theta is phi, and the r phi is minus theta with sine theta in the denominator. Now this is the L operator. If there is no YLM, the YLM theta phi for this state 1s is y00 theta phi, and it is basically y00 independent of theta and phi. So if I operate L on this, I would get 0 from this part, and whatever the corresponding it is the r I would be, it would be there, right? So it is basically 0 times, because it operating on y0 gives nothing because it is independent of theta and phi, right? So that means you can say your 1s state is also eigenstate of L operator. So this clearly says it has to be all of these operators. So that's why your B option is correct. Thank you.